Ladies and gentlemen, I am pleased to report that the OU Americas has achieved its best safety results and lowest workplace injuries in our company's history. I would like to personally thank the men and women of tkE for taking ownership and responsibility for their safety as well as their coworkers. My desire is that all of our employees go home safely to their families at the end of each day. Teaching employees the correct way to work and emphasizing safety above all other factors allows us to work smarter and more efficiently. Our strength is our people, so we must continue to lead and make safety our #1 priority.
This video is on fall protection. ThyssenKrupp Elevator would like to thank Ritz Safety, who is our approved vendor for all safety-related equipment, and Honeywell Miller, the preferred manufacturer of ThyssenKrupp Elevator's fall protection equipment. Special thanks to Tom Dillon for making this video happen, and ThyssenKrupp Elevator's Fort Worth office and Local 21. If you would like to have this presentation live at your location, coordinate with your regional safety manager, and he can get with Ritz Safety and make it happen. Local managers, supervisors, and employees are required to assess the workplace to determine the proper fall protection system to be used. Fall protection shall be used if there is a hazard of falling 6 feet or more through a gap of more than 12 inches between the unprotected edge of the platform or cab and the adjacent wall or barrier. If a hazard of falling 6 feet or more from an unprotected side or edge is present, the employee shall select one of the following options: a guardrail system, a personnel fall arrest system, or a combination of both. Construction. Fall protection shall be worn 100% of the time. This includes all managers, superintendents, inspectors, and any other ThyssenKrupp Elevator employee that is going to visit that job site. A full body harness shall be worn even though tie-off may not be required at the time. When the employee enters a hoistway, the employee must tie off to a lifeline before moving the barricade to enter the hoistway. There are exceptions to this policy. These only apply if no fall hazard is present. However, your fall protection shall be with you at all times. These exceptions are when unloading trucks. When building a cab, employees are not required to wear a harness if this might create more of a hazard. Employees must wear the harness if they are on a multi-cab job or the employee leaves the cab building area. When working in an energized machine room with rotating equipment. When drilling an outside hole or trenching. Or when inspecting an elevator on automatic. If there are any doubts or questions, contact your supervisor and regional safety manager. Special instructions for service. When routine maintenance is being performed on top of a complete operational elevator car and there is a recognized greater risk of entanglement, a personal fall arrest system is not required. A personal arrest system shall be worn in the hoistway when performing work where there is a fall hazard of 6 feet or more and the car is locked and tagged out. Special instructions for repair and modernization. For all repair and modernization jobs, a fall protection plan shall be implemented, enforced, and posted on the job site. A personal fall arrest system shall be worn in the hoistway when performing work where there is a fall hazard of 6 feet or more and the car is locked and tagged out. The personal fall arrest system shall be connected to a suitable anchor at all times when there is a fall hazard of 6 feet or more. When repair or modernization is being performed, the guardrails should be installed as soon as possible. This provides required fall protection while working on the car.
Alright, well, good morning, everyone. My name is Tom Dillon, and I work for Miller Fall Protection, which is a Honeywell company. And I was asked today to come here and talk to you guys about fall protection, the whens, the wheres, the whys, the hows, all the stuff that we need to know. And from the video that you guys just watched, you can see how important it is to make sure that you're doing things correctly. The one thing that I can tell you about fall protection more than any other piece of safety equipment is that if you use it and use it correctly, it will work 100% of the time. Okay? If you don't use it, or you use it incorrectly, the accidents and the severity of those accidents are exponentially worse than any other piece of safety equipment that you could use. The odds are 75% of the time, if you fall at a height of 4 feet or greater, and you are not using your fall protection, or using it incorrectly, you either wind up a quadriplegic or dead. You do not come back to work. You do not go fishing. You do not go hunting. None of those things happen because of what the decision was you made for fall protection. All right? So, a little bit of history and background. Miller Fall Protection is the oldest fall protection manufacturer in the United States. Right? Started in 1944 with a gentleman named Bob Miller, thus the name. Right? So Bob basically was a pole climber for an electrical company, made equipment in his garage. Right? Buddy Study did a pretty nice job, made a whole bunch of equipment in Franklin, Pennsylvania, which is about an hour north of Pittsburgh. Drove down to Pittsburgh, sold all that equipment, took orders for a whole bunch more equipment, drove home, quit his job, and started Miller Equipment. Okay? So then over the years, we've just become a huge global fall protection manufacturer. And that is, we are the largest fall protection manufacturer in the world. Now, I started with Miller Fall Protection in 1995. In 95, the fall protection regulations changed in construction and went away from belts and straight lanyards to full body harnesses and socket lanyards. Bob decided at that point that it would be best to find guys that we could train, know what they need to do, be able to explain what you need to do, so that we can actually help the industry, all industries, with the safety that's going to change. So that's how I got kind of involved with fall protection. Fall protection. The idea is that you will live injury-free every day. Because you can, using your fall protection, just like the guys from the video earlier, you can actually do this and be safe every single day. It is the leading cause of death in the construction industry. And we're going to get into some statistics about that here in just a little bit. According to the 2010 Department of Labor, okay, there were over 100,000 disabling injuries and 815 deaths accounted for working at height. 815 deaths. So you go, oh, well, gosh, that's not really so bad, is it? Well, guess what? There's only about 220 working days in a year of about 8 hours. So when you divide that all out, that's 4 a day. Every 2 hours of work, someone dies from a fall and working at heights. So before we are finished today, somewhere in this country, someone will have fallen and died. That's the statistics. 60% of all the falls happen in the following areas: scaffolding, steel erection, and ladder climbing. And I know from earlier today when I was talking with Larry, you guys definitely fit into that ladder climbing aspect of the job in a lot of cases. So again, you are in a situation on a pretty regular basis where you might not be doing steel erection, but one of the 3 big ones is right in your wheelhouse. So we want to pay attention and make sure when we're doing things that we're doing it correctly, because again, if you do it every day, the percentages go up of if it could happen to you. So, hazard recognition. The best way to do this is joint teams of management, of workers, of safety, the whole 9 yards. Because in identifying the hazards, all right, you have to find out exactly what's going on. One of the worst things that I've ever had to experience was walking through a facility. I've got a plant manager, I've got a production manager, I've got a maintenance manager, and I've got a safety manager. And we're all walking through the plant, and they go, oh, so that's what our issue is. You know, we go up there, and okay, fine, how often do you go up there? Plant manager, oh, we hardly ever go up there. And the maintenance guy kind of laughs. You're like, okay, he goes, well, we go up there all the time. We just make sure they don't know about it. All right, well, that's not good communication. That's not going to help everybody solve the problem that they have with the working at height situation that they're in. All right? You have to be honest. When somebody says, well, how do you do that? You can't give them the answer they want to hear. You got to tell them what really happens so we can really solve the problem that you have. All right? Because if we don't know, if you don't tell someone and you're not honest about it, then there's absolutely nothing we can do to help you. We're going to come up with a solution, but if it's not going to help you, all we're doing is making it take longer or making it be more trouble to do. But you're not going to want to do that. So we all have to work together to make sure the right things get done, and sometimes that's hard. You know, it's hard to tell somebody, you really don't know what I do, this is how we really do it because I have to get it done. But you don't want to hear that. Well, okay, but we need to tell somebody that so that we can make sure everyone's on the same page and we do get the right thing and we get it done. All right, general rule is that any time a worker is at 6 foot or greater off of a walking working surface, okay, you either have to have fall prevention or fall protection. Okay, that's the general rule that we're going to use today for you guys. And that is a construction standard. All right, we're going to talk about the regulations here. All right, so there's ANSI standards and OSHA standards. ANSI is a voluntary group of industry and safety people that come up with regulations that are more stringent than what OSHA comes up with. All right, so if you say our company meets the OSHA standard, well, that is a minimum thing, right? Because if they make the high hurdles 4 inches off the ground for the Olympics, I am a high hurdler. Now, if you bring them up where they're supposed to be, I am no longer a high hurdler because I can't make that jump, right? So again, you don't want to try to strive to meet OSHA. If you are striving to do that, you are way behind what everybody else needs to be at. You need to be lifting yourself up above where that is, all right? So again, OSHA has industrial standards for industry, and they have construction standards. You would fall under the 1910.26 Part 500 for your construction standard. All right. So again, if you want to look something up, that's what you're looking for. All right. Because again, there's a bunch of different standards. So who's responsible? OSHA makes it pretty clear that the employer is responsible for making sure you are safe at your job. So if that entails providing fall protection for you, then that's what they would need to do. But like I said earlier, working together to explain to them exactly what fall protection you believe you need is something that we all need to do together to make sure you get the right equipment, to make sure you can get the job done both on time and safe for you. Okay? The 2 most effective programs involve when employers and employees work together. The program basically has 2 objectives, right? We want to save lives, but at the same time, we want to prevent injuries, right? Because again, a near miss can be almost as bad as an actual injury itself. So again, near misses are important to know. So if you have a near miss, it's not something you want to hide. It's not something you want to, sweep under the carpet, not tell anybody about, and hopefully your buddies don't find out about it, kind of a thing, right? If you have a near miss, if something almost happened, it can almost happen again. And there's ways we can work with you to make sure that doesn't happen. And I know from experience, because the fire department, fire industry is huge on this for the near miss, because it happens a lot. Where we got really fortunate that something bad didn't happen, but we got to go back and find out how do we even get in that situation to begin with, and what can we do to get out of that situation before it even happens again. And it happens a lot, like I said, in the fire service. So again, if you have near misses, if you have little things that, oh boy, that could have been bad, you should be letting somebody know about those as well, okay? Because that's all about the preventing part of it versus just the saving the lives, all right? So, where fall protection exists, you basically have 2 options for what you can do. You can have fall prevention, all right, which would be eliminating the hazard altogether. And this happens a bunch. And again, you guys are the best line of defense to come up with fall prevention more than anybody. Because you're out there and you could say, hey, you know what? If we put up a guardrail, if we put up a barrier, if we moved this piece from up there down to here, it would be better, and then I wouldn't have to climb up there. Well, you need to tell somebody that, because maybe that can be engineered so that you can move that piece. Maybe every day you got to climb up and check that, fitting or whatever it is that's there and climb down. Well, can't you move it down to here, and then no one has to climb? And if you don't have to climb, the hazard is not eliminated. Everybody's better. All right? So again, but those are the things that you can bring back after being out in the field for as long as you have to go, hey, how can we make this better? Let's eliminate some of this instead of having to do this all the time. Now, if you cannot do that, then what you need to have is your fall protection. Okay, and that's basically what we are going to talk about today is if you cannot engineer this away, if you have to get up at height to work, what can I do to make sure that at the end of the day, I'm going home and I'm going whole with all the pieces that I came here with in the morning. Okay. OSHA requires fall protection in the following situations. Okay, walking working surfaces over 6 feet, we talked about that. Unprotected sides or edges 6 feet. So again, same kind of a thing. Anywhere that you have a potential of falling is where you really need to have your hazard recognition for fall protection. Leading edges, okay, so not just off the side but off the front. Any type of formwork or reinforcing 6 feet or greater. Ramps, a lot of people don't think of that. As something slopes up, it gets higher. If you're up over 6 feet, there's something else you have to consider at the end of that. Edges of excavation, pits, wells, and shafts. So again, kind of right in your guys' wheelhouse with the elevator shafts. Fall onto or into dangerous equipment. So again, potential for you guys as well. But again, a lot of people don't think of that, where they go, well, I'm up on this platform and it can't be a big deal. Well, if you fall off and hit a piece of equipment, regardless of what it is, it's going to be a problem, And we're going to talk a little bit about that later when we talk about fall clearance distances as well. Anywhere that there's a hole that you can fall through on a floor. And that happens a lot too, where they'll be in a big facility and they won't realize that, well, we're on the ground level, but whatever the basement is that's there, they could have a hole to put equipment in and out of, and if you could fall through it, then there's a potential for that. You either have to, like I said, engineer it away, or you have to do something for fall protection to avoid falling into it. Okay, forces on the human body. When you fall off of something, all right, you create distance from it. As you create distance, you pick up speed. As you pick up speed, you create force. Suddenly stopping the force creates pain, right? So if you jumped off the abyss and you fell and fell and fell and fell and fell and never hit anything, you would die from starvation and boredom, and then that'd be the end of it, right? But we don't have that. We have gravity. When you fall off of something, eventually you're going to hit something. And when you hit it, that's when the pain comes in, right? So when you fall off of something, how fast or far do you think a 220-pound person at 6 feet goes? Any guesses? You can generate over 4,000 foot-pounds of force on the body. So now when I started in the industry way back in the day, they're like, you can create 4,000 foot-pounds of force on the body. And I'm like, okay, that number means absolutely nothing to me. So you go and you ask the medical industry, you say, well, what exactly happens if you had 4,000 pounds of force? And say, well, it's pretty simple. If something swung across and smacked you in the face at 4,000 pounds of force, not only would it break every bone in your face, make you completely unrecognizable, but it would completely sever your head from your spine. They're like, oh, that's not good. No, that's not good. Like, okay, so what happens if it swung and hit you in the chest? Well, not only would it just crush your entire chest cavity, but the pressure would just make your heart disintegrate. I go, that's not good. No. They're like, if you actually took a full body harness and a steel cable lanyard, straight steel cable lanyard, and you hooked it up and you jumped off into that, the 4,000 pounds of force would be so much that more than likely it would just rip both your legs right off. Because your hips and your thighs can't take that kind of force getting hit. That's bad. That's real bad, right? So we need to eliminate that. We need to make sure that that doesn't happen to you when you fall. So we need to reduce those forces on the body. So now, that's just the forces. What about the speed that we're talking about? How fast do you think someone falls at 1 second? What about 3 seconds? Could it be that much worse than 3 seconds? In 1 second, you can fall 16 feet. So much so that if you sustain a fall, in the blink of an eye, you are more than 4 foot away from where you already were. So all the guys that tell you, as I go to fall off of something, I will spin around and grab, and I won't fall, are full of it. It's not going to happen. Because by the time you realize you are falling, you are already 4 feet away from where you just thought you were. And in the blink of an eye, you were 16 feet away, right? Almost 2 stories away from where you were. So what happens if you just go up a little bit from that? What if it's a minute, a second and a half? Everything goes up exponentially from there. So what happens if it's 2 seconds or 3 seconds? In 3 seconds, you can fall up to 256 feet. So again, you fall very far, very fast. All right? So again, what happens as you're working, just like the video said, I was standing working, I was hanging in a harness. That's how quick it happens. And everybody we talk to says the exact same thing. So again, you have to make sure that you're doing it right when you're doing it all the time. Because in that fraction of a second, you make a huge amount of difference in your life. Okay?
Tom, how often do you hear stories like on our video in a year? How often do you get calls or?
You know, I would say on an average year, I probably hear 3 or 4 times of somebody calling saying, this is what happened. Now, I know for a fact that there are probably 8 or 10 more times that you hear about the near miss stuff, that, you know, maybe didn't happen. And if that's me, you know, one guy in the industry, and there's, you know, 27 of us here in the United States, I mean, every single day there are a bunch. I mean, I know for a fact, you know, just a little quick story. In Arkansas, I had a guy working on a bridge. They had one of our horizontal lifelines up, you know, had 2 guys working between these 2 posts, 2 guys working between these 2 posts. Everything was fine, you know. And the boss had come in the morning and said, here are brand new Motorola radios for you guys. And if you lose one of these off the bridge, you're buying new ones to replace them. So the guy took the Motorola radio, put it in his pocket of his blue jeans, then he tightened his harness down around this so that he wouldn't drop it off and into the water. Right? So he's working, get a phone call later, he's working, and then boom, off the bridge he goes, and he's hanging there on one of our horizontal lifelines. So his buddy, screams, you know, his other 2 buddies, they scream, they run over, they grab his lanyard, and all 3 of us pull him back up on the bridge. Now, not the best rescue procedure on the planet, right? But it worked. Guy didn't hang there 40 seconds, okay? And had he not put that radio in his pocket, everything probably would have been fine. But when he fell, the Motorola radio crushed through his blue jeans and into his leg because of the force that was generated, even wearing a proper lanyard, because that radio just couldn't take it. And of course, you know, radio's strong, plastic, webbing strong, right? Squishy butt, not so strong, right? So that's what happened. You know, so then you get the phone call like, look, guy's still good. Everybody's really happy. You know, he's got a little, you know, a little sore, maybe a little like road rash, but we're all good. Well, but that, you know, a lot of that stuff was avoidable in the whole process of doing it. You know, because again, it's just what are you doing as you're doing things, which makes a difference. You know, but you hear about those kind of things, and it's good, like with your guys, when it works. You know, most of the time when it doesn't work, you don't hear about it too much because of the lawsuits and all that kind of stuff. You know, we hear about it usually after the fact. So, let's look at the fall protection systems. It's what we do and what we believe we do the best. All right? A personal fall arrest system basically has 3 major components. It has an anchor and anchorage connector, it has body wear, and it has a connecting device. That is exactly what you need to remember anytime you're going to use your fall protection. Do I have my ABCs? Exactly what you had in kindergarten. Learn your ABCs. If you can remember those 3 letters, you'll be able to do everything you need to know about fall protection, no problem. Right? But you have to have all 3. First thing we're going to talk about is your anchorage connectors. All right? First thing you want to do, wherever you go, you want to look at what are you going to hook to make the system work. All right? So, when you do that, you're going to walk out and you're looking for something that you believe is going to hold 5,000 pounds. All right? So, when you look up, you're not looking for a sprinkler head. Right? You're not looking for half-inch conduit. You're looking for structural beams. You're looking for, you know, concrete pillars. You're looking for large, strong objects that you're going to be able to hook to so that if you're going to fall, that thing is going to be the only thing left if the whole place blows up. Because that's what we do in the fire service. We say, okay, what's the bomb-proof anchor that's going to stay if everything else, if a bomb goes off in this building, what's the one thing that's still going to be standing there? That's what I want to be hooked to when it's all said and done. All right? Now, it doesn't necessarily have to be right here by your head for it to work, right? I mean, if you're in a building that's 60 foot to the ceiling, that ceiling might be that bomb-proof anchor of 5,000 pounds you want to hook to, right? Just because you want to work down here doesn't mean you can't hook off way up there. So don't just go somewhere and go, well, I looked and didn't see anything. All right? You got to think about it. What is in here that I can use to make this process work? So again, lots of choices for stuff depending on what it is you want to do. Probably the quickest, easiest, simplest, something we sell more every single day than anything else is what we call a cross-arm strap. It's simply a length of webbing with a small ring at one end and a large ring at the other end. So if there's a beam that's right there, you just go up to that beam, you put this over the top, you put the small ring through the big ring, and snug it down. And there you go. Now you just encompass that I-beam. It can be a beam this big, it could be a beam this big. You could call me and say, Tom, I need one of these 27 feet, 9.5 inches. Fine, we'll make you one 27 feet, 9.5 inches. If this is what you need, this is what you need. Okay? Other stuff that we have that's available. We've got our rebar hook anchor point where you can actually hook this over whatever it is and then hook off your connecting it, which we'll talk about, devices to this. All right? So again, this is really good for a horizontal connection spot, right? This would not be good for a vertical. Okay? You do not want to hook this way, because then when you fall, it's like a bottle cap. This will pop that this way, putting a lot of pressure on this gate. We don't want that. This is designed to get hit up in here. All right? So again, horizontally, perfect. Not good for hooking this way around something. Okay? So again, it's all about using it correctly, because we've had too many people take this and hook it around here because it was convenient, because it was there, and like I said, that's bad. Right? It's going to get a bad flex to it if you were to fall into it. So don't do that. Use it properly on something like this. This is a 2.5 inch gate opening. So if it can fit over 2.5 inches of beam, whatever, then you're good to go. All right? We have beam clamps. So if your I-beam has a flange on it, right, you can simply put this up there, pull the pin, slide this down to whatever size you want. It'll go from about 3.5 inches up to 12 inches. And anywhere in between, it locks into place. All right? What's nice about this is once it's on the beam, it's not so snug on the beam that it won't move. You can actually slide this along, and if you had to move a little bit, you could slide it on a beam as long as there weren't any extra bolts or cross members or whatever. But you could put this up and boom, you'd have it there. And if you had a nice beam around the length of this room, you could literally just scoot this down with you as you went the whole length of this beam and work the entire length of this room. Okay? So again, another option. These can be put on the face of a beam. So again, you can actually put it on this way. You can put it on the top of a beam, so this will actually sit because it's out of the way. All right, so again, you can use these in a lot of different ways. Excuse me. We actually have one, not this one. If you were to put this one on a beam like this, it would just keep falling down, right? That's bad. So we actually have one you can put on the face of a beam, lock it into as close as you can get it, and then it has a ratchet on the end that will actually tighten it down, so this would actually stay on a beam like this. All right? Now, why is that important? Because a lot of times, when you're working, you might have a beam on this wall and a beam way over there somewhere, but you want to work in the middle over here, right? There's really nothing good here, so what do? Well, you could take one of these and put it on this beam, another one and put it on that beam, and then you can get one of our temporary horizontal lifelines up to 60 feet, right? So they'll go from about 10 foot all the way up to 60 feet. You hook it on this side, you hook it on that side, tension it, now you've got whatever length it is, 40, 50, 60 feet, to walk between these two beams to be able to work in the middle, as opposed to trying to hook up something above you, or maybe there isn't something above you to be able to work. All right? So again, there's a lot of things we can do if you tell us, this is the thing I found a hook to. Okay, what else? Where else do you need to go? What do you need to do? Let's work this out and make it happen. Okay? So, we also have push-through eye bolts. A lot of beams have holes in them. They come with holes in them so that you don't have to burn holes through them to bolt stuff together, right? So again, if there's bolt holes that are there, you can simply pull this down, push this up through the bolt hole, lock it in place, hook up your connecting devices. You can use this both in a horizontal or a vertical beam. So this one you can actually take and put in the beam this way, because the shear factor on this one is good, okay? So you don't have to worry about it. So this can be used in a vertical or a horizontal beam, either way. As long as the hole is just big enough for this to go through, and it locks this in place. All right, so no slots. It happens a lot. Guys go, oh, I'll put this up on the Z-purlin that we've got. Well, that's a slot. All right, because again, it sounds real good. I'm going to hook it this way, but if you start working and it starts moving and it falls right through the slot, that's a problem. All right. So again, it's got to be a circle, got to be a hole. Push this up through, locks into place. All right. We have D-bolts. If there's somewhere that you know you're going to go on a regular basis, just put a D-bolt up. All right. You can get any size bolt you want to put this on. You can put these absolutely anywhere. You can put them this way, this way, this way, this way. However you want to hook this bolt up to something, you can hook this bolt up to something. All right? So again, it's there. We've told people before, if you need to, if you want to, you can put some paint on it to color code it so it's bright orange or bright green, whatever. You know it's there. Use it for fall protection. That way there's something there for everybody to hook to and they know it's there. All right? So these bolts are great. Inexpensive. You can put them all over the place. They're semi-permanent because you can put it up and leave it up. Or you can put it up and after a while you can take it down and move it someplace else. Just unbolt it. Right? We also have these for concrete, not just metal, but for concrete. So again, if you have a concrete wall, solid concrete, again, concrete, not brick or block, 3,000 PSI concrete or greater. Right? Usually 4 inches thick or greater. Drill a hole into it, put the anchor bolt in, you're good to go. Right? You can put in the concrete ceiling, concrete floor, concrete wall. As long as it's solid concrete, you're good to go. All right? We have also for concrete, the Miller Drift. Basically, you would drill a 3/4 inch hole, okay, 3 inches deep into a minimum of 4 inch concrete. You just push this down, push that up into the hole, and it wedges itself right in. All right? Now, you do not want to push this all the way up into the hole because you need to be able to pull this back a little bit to get the pressure off to get it out. So again, what you want to do is you want to push this up till it's about to the edge of this, and then it'll lock itself in place. And then you have plenty of room to be able to push back up and get this out. So again, they are removable. You can actually drill a 3/4 inch hole, 3,000 PSI concrete, about 3 inches deep. You can put one of these in right here. You can put one in down there, and you can put a horizontal line between them. Right? You can put one in here and hook your fall protection off to it. You're done working here, you can take it out, go over there, put a new hole in, boom, put it over there. So again, they work fabulous in all kinds of applications, right? Again, quick, easy. So now let's go from the A to the B, which is body wear. There's only 2 types of body wear anywhere in the world. You can either have full body harnesses, right, which is what we're going to talk about, or you can have belts, all right? Now, as soon as you say the word belt these days, everybody freaks out because belts are bad. Belts are bad for fall protection, all right? They're not bad for positioning or restraint, all right? So they're not completely illegal to have a belt. It just depends on what you're doing with it, all right? So, for example, if you were on a roof, say, and you put an anchor point in the middle of the roof, and the furthest point from that anchor point to the edge was 30 feet, and you took a rope that was 20 foot long, and you hooked it to that anchor point, and you hooked it to a belt, and you walked around that roof anywhere you wanted to go, you would be restrained from getting to the edge, which would have 0 potential falling. You could never hurt yourself. There you go. You have restrained someone from falling. So what I want to do is make sure that everybody here understands the proper way to put on a full body harness. Right? Now, first thing you're going to find when you find a full body harness, right? They're always hanging up nice and neat. They're usually in little plexiglass cases of their own, combination lock to get to them. I like to put a little light on mine with green or pink. You guys are all sitting there like, yeah, you know, who keeps their harness like that? Nobody. You guys will wad these things up into the smallest possible ball you can get it in, and then you shove it in the back of the truck. You shove it under the seat. You put it in a bag. You shove it in a bucket. Whatever the case might be, right? So here's the thing. I understand this is how you have to keep them sometimes. Get it. But if you're the guy that wads it all up, you should also not be the guy complaining about it. Right? Because you did it. If you can keep it hanging up somewhere like so, the tangle fairies do not come in the middle of the night just to screw with you and tangle the harness up. Right? It's when you knot and wad it all up is when that happens. So if you can keep it straight, it'll stay straight. But if you can't, and I understand that, when you have to take this thing and wad it all up to put it somewhere, because after you limit it on space, it's going to look like this. Here's the thing. when you find a harness, no matter what harness it is, always pick it up by the back D-ring, or what we call a dorsal D-ring. You can always tell which ring it is, no matter how many rings are on a harness. It's the only one that has a pad around it, like this pad right here. All right? So if you have side D-rings and front D-rings and back D-ring and shoulder D-rings, the only one that's going to have a pad like this is the back center D-ring. Right? Pick it up by that ring. And the reason why is because at that spot, these pieces of webbing do not have enough tolerance to get all tangled. So if you start at the beginning where it's not tangled and go, okay, I'm going to follow this one down. Okay, that had to flip this way. You can take the next one. That one's good. You'll be able to see pretty quick and easy what straps are tangled and what ones are not. And you'll be able to untangle them. But if you pick this thing up sideways and then, it's all tangled, I don't know how, well, yeah, of course you don't know where it goes because it's not straight. Okay? So pick it up by that back D-ring. When you do that, you can see that there's a D-ring side, right? And there's a front side. So what you want to do is you want to take this D-ring and you want to hold it up against your chest. At that point, there's two straps that come out the front. Put one hand on one strap, put one hand on the other strap. If you can get it untangled and this far, you are 95% of the way of putting this harness on and putting it on correctly. You've done the hardest part of any harness right now. Because if I were to hold this up like this, anybody in this room could come up and put one arm on one side and one arm on the other side, and you'd have this harness on, right? The key is you don't need any help. But you do not want to let go of these two straps. There is no throwing in fall protection, right? So again, while holding these two straps, if you just put your hands behind your head and let go, guess what? No matter how poorly it falls on your body, D-rings up between your shoulder blades, arms are through the armholes, leg straps are down by the legs. Everything is where it's supposed to be, right? You just got to kind of adjust it a little bit. And I'm sure everybody here can do the adjustment parts. So again, first thing you want to do, you want to make sure that that D-ring is flipped back up the way it's supposed to go, right? And it's laying flat in the middle, center of your back. So then you take your chest strap, okay? This one happens to be a mating buckle, all right? Again, a lot of people call them push-through buckles or parachute buckles, but it just simply sits right through, sits on top of the other one. The reason why I put that one on first is just so when I go to do my leg straps, the chest ones aren't falling off the whole time. All right? So you don't want it on too tight. You just want it kind of on to hold it together. And you want to go down to a leg strap. You want to buckle one leg strap in. You want to grab the other leg strap, put that in, and there you go. The harness is on. There was no cussing. There was no crying. It didn't take 20 minutes. All the stuff that people always told me isn't really true if you actually pick it up and know how to put one on, right? Okay, so again, easiest thing to do, now that you know, if you don't do it that way, practice it a couple of times, and no matter what harness it is, you'll be able to put it on quick and easy from here on out, right? So, now you got your harness on, you're ready to go to work, right?
No.
Okay, good, because this means yes, and this means no. We're coming back to that, so you got to adjust it. Very good. If you wear your harness the way I am wearing my harness right now, I guarantee you, you will not get hurt, because you will die. That is not hurt. All right? Well, here's the thing. Falling out of it, maybe, but unlikely. What's more than likely to happen is, if you fall out into a harness, wearing it the way I'm wearing it right now, and this strap, this torso strap, were to slide out just that much, all right, you're not going to break your arm. You're actually going to sever your arm completely from your body, all right, because this is 7,000-pound tensile strength load webbing. When you fall into this, and this thing smashes into your arm, your shoulder cannot take that kind of pressure. More than likely, rip your arm right off the side, right, which pretty much means you're going to bleed to death pretty quick. Right? That's not good. Now, the good news that you ripped your arm off is the fact that you probably, at the same time when you fell like this, since you didn't fall correctly, your neck probably went like that, and you snapped it pretty much instantaneously. So you didn't even know you ripped your arm off because you already broke your neck, and you didn't have to worry about that at all, right? So that's on the top side of the harness if you don't adjust it properly. Let's go down to the leg straps. From the day I started in this industry, I never understood why anyone would let their leg straps dangle down around their legs like this. Because this is how I've always seen it. You're going to be hooked to a large stationary object. That object isn't going to move. You're going to be tethered to that object at a distance, all all right, that isn't going to change. As I said earlier, when you fall off of something, you fall at a very, very high speed, right? So when you fall off of that and you get to the end of that tethered line, these are going to go up at a very, very high speed. Okay, I'll let you think about it for a minute then, if that's what it takes, right? But here's the thing.
4,000 pounds of pressure.
Yeah,
being
exactly,
added
yeah.
to a certain region.
Yeah, it could be. Now, so here's the thing, though.
Wait,
okay?
no more kids?
So, oh no, I'm not saying that at all, because again, the key is what's nice about this, and it's not necessarily today because there aren't any ladies in our class today, but fall protection, unlike anything else, is an equal opportunity killer. Right? We don't care if you're a man or a woman, child, whatever. If you fall into a harness wearing it this way, you're going to die. Because it's not about being a boy or a girl. The largest arteries you have in your body are in your thighs, your femoral arteries. They pump more blood up against gravity every day than your heart does. You know, your heart pumps it out, gravity falls, your legs are what pump it back up to your heart. Those, let's just say, are big arteries like this. And then you fall, and this slams up into them, and it goes like that. And that's like having a massive heart attack. And it's like having a massive heart attack until someone comes and gets you down. And that's the problem. You cannot have a harness moving around on your body at all. Right? So you need to snug it so that doesn't happen. So the first thing you need to do is you need to make sure your D-ring is even in the right place. Because like right now, my D-ring, just by standing here talking to you, I didn't do any work, right? Yeah, I consider this work, but not real work, right? So I haven't done any work, and yet I can't reach that D-ring. That's completely in a spot that is you can't get to. And how many times has somebody done that? You know, I can't reach my D-ring. Then it's in the wrong place. And the reason why it's in the wrong place is because you started with it in the wrong place, right? So again, you want to start with this D-ring positioned up so it's between your shoulder blades, right? Like so. So if you can actually take your hand and touch the back of your head, you should be pretty close to being able to touch that D-ring every single time, which means you should be able to hook your own lanyard up into your D-ring. But if you start it in the right place, it'll stay in the right place. So then what I normally do is I take the chest strap and I tighten it across again, because now that it's good and loose, all right, this will pull these two straps together, and then once they're together, later they won't be able to slide off my shoulders. Then I go down to my leg straps, and I don't care which leg you start with, left or right, doesn't really matter, but you take it and you snug it down so that it's tight. People say, well, how tight do I need to make it? I'm not looking for you to cut off the circulation to your feet. It's not what we're looking for here, right? You want to have just a little bit of room in there. What I tell people is if you take your hand flat and you pass it between the material of the clothing that you're wearing and your full body harness, and you can get your fingers in there and it's a little snug, that's all the room that you need. All right? And I say between the full body harness and the clothing that you're wearing because it will change, right? You'll wear more clothes in the wintertime than you do in the summertime. You know, you can gain weight, you can lose weight. Don't ever tell yourself, well, I'm the fifth grommet guy, so I'm always going to put on the fifth grommet. That's not the case. Make sure it fits you the day that you're wearing it. And I know you might think, well, every day is, you know, I work it every day. It's still going to change, right? So just make sure it's right the day you're wearing it, all right? So again, get this one, you're ready to go. So then you go over to the other leg and you tighten it down, all right? So you check it. Put your hand in there. It's supposed to be good and snug. So as you do that, then you have to adjust what you call these torso straps that are right here. But as you do that, you notice that leg strap 1 is on 5, leg strap 2, let's say, is on 3. Is that possible? Do you have one on 5 and one on 3?
One leg's way stronger than the other.
Well, that's impossible. It's unlikely, though. I mean, I can tell you that, okay? The odds that you have one 50-inch thigh and one 20-inch thigh makes you a human oddity, all right? Not likely, okay? Most people's bodies are symmetrical. So if it's off that much, something's probably wrong, all right? Now, in all the time I've been doing this, there's really only 2 things that I've ever found that it could be. One of them happens probably less than 5% of the time, and that's you got the leg strap twisted or something's not right, and you just, as soon as you figure that out, it'll be easy to fix, you know? But that's the irregular, hardly ever happens. 95% of the time, if your leg straps and you look at them and they don't match, one's longer, one's shorter, everybody, man, woman, whatever, is doing the wrong thing. And you're probably all doing it right now, don't even know it. Anybody got to guess what that is?
Your wallet or something in your pocket.
All kinds of stuff in your pockets. Not just your wallet, your keys, phones, radios, pens. My favorite are wrenches and screwdrivers. Because guys will take a wrench and a screwdriver and put them all in his back pocket, right? And then he'll put that leg strap around it, just like my buddy from the bridge did with his radio. And then, what? You fall, and where do you think screwdriver goes? You know, solid steel screwdriver, big strong webbing, squishy button. Do the math, right? But people don't think of that. Here's the other thing. I was giving this class several years ago, had a nurse in the class. She's like, oh, you know, it's just as bad as that. And I was like, I can't imagine what would be worse than getting shoved in the leg with a screwdriver. She's like, all the guys that have pens and stuff in their pocket right here. She goes, because if you fall with that and it catches, right into the jugular it goes. Hey, how about that? Yeah, bleed out profusely right out the pen. How nice, and there you go. So again, all the little things that you don't ever even think about make a big difference if you're one of those guys that sustains a fall between, am I going to live through it, am I going to go to the hospital and have lived through it, or am I not going to live through it, right? But again, if you don't plan that before you fall, if you don't plan for, today is the day I might fall, I'm not going to put screwdrivers in my pocket, I'm not going to have a big pen right here in my pocket, I'm going to get a tool pouch, I'm going to get a tool bag, I'm going to do something else, makes a difference, right? So the top is good and tight, the bottom is good and tight. Now I just got to take this slop that's out of the middle here and get rid of that. Depending on the harness you have, you either pull up or pull down. It's the only two directions you can go. So you normally just grab one side and pull up a little bit. You grab the other side and pull up a little bit. And again, these two sides should match, right? I don't need you to get a mic out and take all afternoon going, get them to match. This matches. If they look like this, they don't match. If they look like this, they match. All right? Now, again, I don't want you to pull these so tight that you hunch yourself over all day. Right? I'm not looking for that. I'm not looking for you to walk around like this. But again, you want them to be snug. This chest strap actually drops down a little bit. They're adjustable for that reason. So again, when it drops down, you can't leave it here. It's not called a belly button strap. If it was called a belly button strap, then I'd let you leave it there. But we make the harnesses and we call it a chest strap. That's where I want it. I want you to put it back up across your chest. It's not a neck strap, all right? It's across your chest. That's where it goes, all right? So adjust it so it fits you at the time where it's at, all right? The last thing you want to do is you want to take any of this excess webbing from where you did your adjustments and you want to tuck it back into the harness. Every harness we make has what we call these elastic keepers, and they're just basically little pieces of elastic that'll hold your harness material in closer to your body so that it's not flopping all over the place. This side's right, this side's, you know, needs to be tucked in still. Okay? The other thing I wanted to talk about real quick with harnesses is positioning. Okay? So you put, now you have to realize I do work for the company. I can have anything I want, so, and I actually kind of, we helped design this one, so this,
Yeah, we'll never do that way. Can you move over there by the cabinet and do a little?
actually, I probably could, yeah, this one I probably can, as a matter of fact, but, all right, but the reason why I'm putting this one on is to show you guys for positioning, all right? So if you have your full body harness on, and you're using it for fall protection, that's great. You've got your deer in here, you're all hooked up. But let's say you want to work on something, you climb up to it and you go, oh man, I'm gonna have to grab onto this and hold on and do my work. Right? By definition, your left hand is a piece of positioning equipment. Because if you were to let go of your left hand and fall out of position, right? There you go. So what happens is people go, well, I want to get up there and work, but I want to use both hands, or I want to be able to do some stuff, but I still need my fall protection on, but I want to hold myself here. That's what the side positioning rings are for. Never for fall protection. You never want to hook this off because, again, you're going to hurt yourself if you fall, whatever the case might be. But what you can do, you can take a rebar chain assembly, for example. You hook it to one side, you hook it to the other side, and then you can hook this in front of you, holding you in position. You can do all the kind of work you want to do and never have to worry about it. You still have fall protection on. You still are connected here. This is just holding you in a position to work. All right. Now, it doesn't have to be hooked right in front of you. Let's just say, for example, you've got something that, you know, might be 9 foot around. You want to go around. Well, you just got to go get a really long rope lanyard, right? You would hook this to you, go all the way around this 9 foot thing, and then back to you. It doesn't change you holding into a position and still working. That's all these are for, right? So here's the thing. This is what I tell people. If you don't need to hold yourself in a position like that, ever, these are the most expensive flashlight holders you will ever buy. So don't get them. You don't need them, guys. Oh, I want all this. No. Get what you need to do the job you need to do, and don't worry about whatever everybody else has got. All right? If everybody else in their job's got front D-rings, and side D-rings, and shoulder D-rings, all that's doing is adding weight, and that extra weight adds heat for you, and it adds cost that you don't probably need. But if you do need it, then you need to get them. You need to know what it is you do, what you're doing to get the right equipment for the job. Okay. The connecting device is the critical link in the entire system. All right. This is the most important part of all fall protection. To me, if you get this part right, you shouldn't have any problems. But if you screw this part up, that's when it becomes painful. Because here's the thing. If you put a harness on so tight, right, that you're turning as blue as your shirt, your eyes are bugging out of your head, you're all scrunched in there, and you got a big old monster anchor point with a great anchorage connector on it, and you mess the distance up, more than likely, 75% of the time, you're quadriplegic or dead, right? But maybe you're not wearing your harness as tight as I'd like to see you do it. Maybe your anchor point is questionable at 5,000 pounds but close. You know, maybe the anchorage connector that's going around it could be a little snugger up. Maybe, but you do this part right, you will get forgiveness, and you will never do it again. I guarantee it. But you have to do this right. So if we have any questions about this as we go through, please ask. All right? Because it's not difficult, but it is something that you need to talk about. All right. All right. There's several kinds of lanyards you can get. Okay. There are rope lanyards. There are web lanyards. And there are steel cable lanyards. Those are really the only three types of materials you can have lanyards made out of. Now they can be, stainless steel or galvanized. They can be nylon, Dacron, or polyester. But basically, you can either get rope, webbing, or cable, and that's it. Right? They have some similarities and they have some differences. Right? For differences, it pretty much comes down to, like I had said earlier, matching the job you do with the piece of equipment you're going to buy. If you say, hey, I want to buy the most economical thing that's going to last the longest and do the best, then most of the time you would say, well, a steel cable lanyard. I mean, it's got, UV protection better than webbing and rope. It's got chemical resistance, depends on if it's not corrosives. But for the most part, you buy one of these, they can pretty much last indefinitely, right? Unless you're an electrician. That'll probably be bad, because it's going to light you up like a Christmas tree, right? So if you forgot to tell me you're an electrician, that would be a problem, right? So again, you got to make sure that you do it right. So you go, okay, well, we'll go ahead and get a web lanyard then, because we're going to give it to everybody. So if we can give it to everybody, then an electrician can use this too, right? True, but let's just say you're going to take this web lanyard, and the day you're going to work, it's going to rub, on this table like that all day, right? Is that going to be a problem? Mm-hmm. Over time, it's going to be a problem, to somebody. Maybe it's either going to wear out the webbing on this lanyard or it's going to wear out that table. Either way, someone's not going to be happy, right? So we have to make sure that if that's what's going to happen, do we need to get another piece to put there so there isn't any friction? Do we need to figure out what the application is to match the best piece of equipment we can with what it is you're doing? Or it's a problem, because one lanyard isn't going to work for everybody, or we'd only make one lanyard, right? Okay, so that's pretty much how they're different. How they're the same, they're all 6 foot long, and they all have locking snap hooks on them, right? So now by a locking snap hook, what I mean is it takes 2 motions to open it. The back does absolutely nothing without activating the front. The front does absolutely nothing without activating the back. You have to do 2 things at one time to make them work. Right? It is locking snap hook. This is a non-locking snap hook. This is just a little squeaky, squeaky, opening, opening little snap hook, right? These are illegal to use for fall protection. As the regs changed in 1995 and went into effect in 97, these became illegal to use. Miller Fall Protection stopped using these like in the 70s sometime, late 70s, because we realized early on that this snap hook hooked into a ring, like so, for fall protection, is bad, all right? Because if you fall, you don't have a lot of control over it. You're going to bounce this way or that way or how it's going to happen. But I do know this, when you fall, you're going to bounce a little bit, all right? Even with a really good shock absorbing lanyard, you still have a little bounce. The problem is if you bounce and this touches, you fall out, okay? No magic, nothing on my sleeves, right? It's pretty much physics. If this touches this side, it'll open right up. That's bad, right? So we stopped making these on our lanyards because when you take a locking snap hook and put it into a ring, there's no way it's going to touch both sides. So because it can't touch both sides, it is locked until you unlock it, all right? So you want to make sure that you always have locking snap hooks. Well, here's the thing. If we haven't put these snap hooks on our stuff in forever, and no manufacturer who makes fall protection has been able to do it since 97, why, after all these years, do I still even bring this up? Because sling manufacturers and pulley manufacturers and all those guys don't have the regulations we have. And guess what? Their webbing looks like my webbing. Their rope looks like my rope. I mean, rope. It looks like rope. You know what I mean? So the thing is, if you grab one and hook it up and you don't know, or you're in a hurry, or it's not a big deal, or whatever, it's a problem. So again, they are out there, and people have made mistakes and used them. You know, not many people still have them around on our stuff for fall protection, but they're still out there for other stuff. So you have to make sure you get the right thing, you're using it properly when you're using it. Okay? Now, the other thing I said was all these lanyards are 6 foot long. The reason being because way back in the day when they were changing all the regulations, they decided that the average worker of 220 pounds and 6 foot tall was what was going to be out there in general in construction industry. So they said, okay, average worker 6 foot, 6 foot's going to be it. They said, okay, great. So if we give a guy a 6 foot steel cable lanyard like this, right, and we hook it up to an I-beam and we hook it up to him, which in this particular case to test him is just a solid weight. All right? So you take that and you hook it up to a 220-pound weight, which represents a 310-pound person, and you drop it like this, all right? That generates almost 4,000 foot-pounds of force. That's bad. And I will show you this when we go outside here in just a little while, how hard that really hits something. So they go, oh, that's bad. Well, that's ripping legs off. That's killing people. We can't have that. But we can't make them shorter than 6 foot because people can't work. We can't make them longer than 6 foot because that would make it worse. So you can't use a steel cable lanyard. They're bad. So fine, we won't use steel cable lanyards. We'll get webbing lanyards, right? Because the next best thing from steel cables is webbing because they're durable and strong. And so you hook that up, you hook up the 220-pound weight, which represents a 310-pound person, and boom, you drop it. Well, because the webbing actually stretches a tiny bit, not a bunch, but a little bit, because remember, it's still sewn, so it's going to stretch a little bit. It drops from about 4,000 foot-pounds to 3,000 foot-pounds. Problem is, to be legal in fall protection, you have to be under 1,800 pounds of force. So I'm not great at math, but I know 3,000 is way more than 1,800, so web lanyards are illegal. So that's when the guy said, but that's why those construction guys of old were so smart, because a 3-strand spun rope, like this, all right, stretches a third of its total length when you go to use it, always. So what happens is if you got a boulder in your front yard and you want to move that boulder and you got a 100-foot piece of rope and you hook it to the boulder and you hook it to your truck's going to move 33 feet before the rope gets tight enough to start moving that boulder. Well, the same thing happens with a 6-foot piece. You hook this up to that same beam, you hook this up to the 220-pound weight, they actually raise the beam up another 2 feet because when they drop this, if this 6-foot lanyard darn enough doesn't stretch out almost exactly 2 feet. Which is great because the force that it takes to stretch this is what comes out of you, comes out of the fall, and it goes into the mechanism of stretching this, right? That's what we're looking for. The problem is, depending on how old or new the rope is, and what diameter the rope is, be it half, 3/4, 5/8, whatever, you're somewhere between 2,000 and 2,200 pounds of force, making it illegal to use for fall protection. At that point, we ran out of stuff, and that's a problem, right? So they said, well, what exactly is the problem? Well, the problem is the stopping of the force. Because remember, when you create distance, distance creates speed, speed creates force. The faster you stop it, the harder it hits. So we need brakes. We need to stop a little slower. We need a parachute. We need something to make this better, but we can't make it another 20 feet to make it work, right? That's bad too. The farther you fall, even though you're ripping something away. Now we're talking how high do you have to work to make the system even work, right? Well, way back in the day, Bob Miller actually invented what we call the soft stop, which is a deceleration device, or what a lot of guys call a shock absorber, all right? And basically what this is, you can add this to any one of these 3 lanyards. Just by doing this, take your lanyard, hook this into there. Now you have a legal lanyard. Illegal? Legal, all right? And the way it works is actually pretty simple. Inside of this package, there is a strength member. This is a solid piece of webbing. There is a sewn material, kind of looks like Velcro, kind of works like Velcro. It's not Velcro, but it's sewn together back at our factory like so. So what happens is this all gets folded up into the pack, and the pack gets attached to a lanyard. When you fall and you get to the end of where the lanyard is, the pack rips open. And the force that it takes to rip this away from itself comes out of you, comes out of the fall, goes into the mechanism of ripping this, and that's what slows you down. This will consistently get a 220-pound weight, which is a 310-pound person, down to about 830 foot-pounds of force. Well under the 1,800 that you want to be. All right? We have to do this in less than 3.5 feet. So again, if you can stop somebody in 6 inches, that'd be great, but by doing that, you might be a little higher on the forces. All right? But again, you don't want to go more than 3.5 feet because then the lanyards are illegal because you've fallen farther and slowed down farther than you're allowed to go. Okay? So again, that's how all these work. Now, what we've done over the years is we've eliminated a lot of the hardware. So we'll actually sew the pack right to the lanyard. So then you got rid of some of the weight, some of the cost, things like that. Okay? But like anything, people go, "Oh, that's nice, but what else can you do for me?" Well, that's when Bob and the guys in our engineering department invented the Miller Manuard, and that's what this is. The way the Manuard works is, this is a 6-foot shock absorbing lanyard, but the outside, the green part of this, is actually your strength member, like the black piece of webbing on the other one was. That's your strength member. Inside, because this is sewn into a tube, sewn into a circle, inside is your deceleration device. So people go, well, why are they always so scrunchy like that? Well, the reason why they're scrunchy is because we know how long they're going to go when they're deployed. So we start with that amount, scrunch it all up, put the deceleration device inside, because remember, the deceleration device inside is going to get longer. So the outside needs to get longer with it. So that's how they work. All right? And what makes ours really nice is we actually add the little warning flag to it so that the first stitches that rip come out of this flag. And the reason why is because if you were to, be ripping on this and pulling on this and doing stuff with it, you could actually put enough force on it to pop this out, but only a little bit. And if you did that and then you fell a second time into it without knowing that, it would rip much farther because, again, once you start something, it's easier to continue to rip it than if you start from the beginning to rip it. Most of our competitors that make this exact same lanyard say you have to measure it every single day to make sure it's the right length. Ours is if you pick this up and your lanyard still has your warning flag attached to it and it's not ripped open or missing, your lanyard's good because it hasn't been ripped open yet. Okay? So that's how these work. So, now, everybody here has worn fall protection, right? I don't use the word use fall protection because most of you have probably never used fall protection. Never actually fallen into it to use it. You wear it, but you don't actually use it, right? So anyway, you put your fall protection on. You have a 6-foot shock absorbing lanyard. You climb up to where you're going to work, and you hook this off to your crossarm strap right around a beam right here. How far away does this snap hook need to be from whatever it is you don't want to hit to make sure you don't hit it? 10 feet. 10 feet. You're dead. You're dead. Anybody else dying today?
1 foot.
You're definitely dead.
So we're going 20, 15?
All right, so now, let's go back. You guys all wear this stuff, right, or have worn it? But you hook this thing up, And it's an exact number that you have to know to say from here to there is how far I need to be away for this to actually work so I don't hit anything and hurt myself or kill myself.
9.5 feet.
All right. You have to have a minimum of 18.5 feet away from what you don't want to hit from where the end of this lanyard is hooked to make the system work right. If you do not 18.5 feet, 1, you are potentially going to get hurt, and 2, you are illegal. If OSHA sees you doing it, it is a violation as if you were not wearing anything at all.
That 18 feet is easy vertically,
Right?
but around us,
It's not easy vertically either.
Well, right, but I know, but we're talking about the way they work is gravity.
Right.
So if you're right, so so if you're working at a shaft or whatever, right? It's if you're only on the second floor and you're only 10 feet away from what you don't want to hit, 18.5 feet is how it's going to work. So now what you're going to do is you're going to be hooked up to something right here like that, right? So we come up with our 18.5 feet because from here to here is 6 foot for your lanyard, right? Everybody with me? Right. Now, from here to here is 3.5 feet for the deceleration device. That's the part that's going to rip all open, right? We're at 9.5 feet. What is at the end of 9.5 feet? U. So you add in 6 feet for that, right? Making this 6 foot U. So you're at 15.5 feet, right? What if you weigh a little more? What if it's, it was after Christmas and whatever the case might be? There's a lot of factors in there to go, what if you measured this and you thought it was 18.5 and it's only 18 foot, 4 inches? Really, does it matter? Yeah, because guess what? 2 inches, you hit the ground versus not hitting the ground, you break both your legs. You put a femur through your thigh, you die, right? So guess what? You have to add in a minimum of a 3-foot safety factor.
Can I get you to put some buffer stands
Make
there at
this
the bottom too?
18.5 feet.
Distance away from us?
All right. What's that? Yeah. Well, that's what I'm saying. Now, okay, so now here's the thing. This happens a lot. This is one of the... So let's just say this, right? This side over here, we're going to on this side. This is a roof a guy is working on, and he measures down to here, and he's 22 feet away. So he's like, I got a little bit of room plus my safety factor. I'm great, right? Till a guy parks a fork truck right here, right? Does that still work? No. Did he change it? No. Did somebody do it? Yeah. But guess what? He's the one that's going to pay. So if somebody pulls a fork truck there, somebody puts a propane bottle there, somebody does something else, you got to fix this. Not him, unless you can get him to move it. You got to fix it. Because you're the one that's going to fall off something and hurt yourself. If you do not have 18.5 feet from the other end of where you hooked this lanyard, you can get hurt, and OSHA is going to tell you it is not like wearing anything at all, no matter how good you think you're hooked up, because it is wrong, all right? So if that's the case, if that is the case, right, and like he said, if you climb up to 6 foot, and from my feet to the middle center of my back is about another 4 foot, that's 10 foot, right? So now I take a lanyard that's 6 foot long and then go up 10 foot from 6 foot, I'm what? 16 feet away. It still doesn't work. So guess what? Just because you have a full body harness and a 6-foot shock absorbing lanyard hooked up doesn't make you safe. And it doesn't make it right. So all that means is you have the wrong piece of equipment. In this particular case, if you have any of these going on, you have to get the self-retracting lifelines.
Yeah, apparently we need to get those for everybody then.
The way the self-retracting lifeline works is, right, very much like the seatbelt in your car. It's a centrifugal force drum brake. As you walk out, it comes out. As you go back, it comes back. As you walk out, it comes out. As you go back, it comes back. If you fall, they lock up. They have to lock up within 24 inches. These little ones have such a small drum on them, they lock up within inches of where you work. Okay?
What's the deceleration factor?
Well, that's just it. Because you don't generate distance or speed, you don't generate force. This is still right around 900 pounds of force when you fall into it. Think of it like this, guys. I could take my lanyard, hook it up to my back, step up on this chair, right? Step up on this table, move that ceiling tile, and hook my lanyard up to a cross-arm strap on a beam in the ceiling. And I could jump off this table, and I would hit the ground right where I'm standing, because that's not 18.5 feet away. Or I could take this lanyard, which is a self-retracting lifeline, climb up on that chair, get up on this table, hook at the exact same spot, jump off this table, and I wouldn't even hit the chair that's sitting next to the table. Okay, now wait, we're not done with this yet. All right, let's think about this for a second. Let's just say, all right, like I said, these work great. Right? You fall down, they lock up. You figure out to fall up, they'll lock up. That's great. They come in a bunch of different sizes. This is a little 6-footer. From 6-footer, they go to 9-footers. From 9s, they go to 16s. 16s, they go to 20s, 30s, 40s, 50s, 65s, 75, 100, 120, 125, 130, 150, 175 foot long retractable lifeline. So you can put a big one of these up and climb up and down a 150-foot ladder all day long if you needed to. All right? And if you fell off one rung, it'll stop before you get to the next rung. So that's great. All right? But they are inanimate objects. All right? If you don't use them correctly, they still will not work. So for example, let's just say this is a 30-foot self-retracting lifeline. You climb up to the top of the ladder you're going to work at, and you get this hung up. And you're climbing up and down all day long, climbing, 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 and everybody's happy, right? You finally get done with doing that stuff, and now you got to go work over there. So you take your 30-footer and you walk out that way, 30 feet. What's going to happen?
You're going to fall 30 feet.
Yeah, exactly. But guess what? I never said you were 30 feet high. Just because you have a 30-footer and you walk out on this roof 30 feet, if you're only 20 foot up, you still die. This thing doesn't go, come back, you're too far away. It's an inanimate object. If you don't hook it up right, it's still not going to work. And that's the other thing that happens a lot. Okay? You hook this up like this, and it's 30-footer, and you walk out 30 feet. All right? And I've done this on job sites. You ask a guy, okay, if you were to fall right now, what is the one-word answer everybody gives for where they're going to go? Down. Are you going to go down? No. You're going over there. And that's the problem is when you do that, if you hook it up over here and you walk out that way, what's 60 feet away from you that way? Because that's where you're going. And the problem is when you fall off of something, you create distance. Distance creates speed. Speed creates force. This is the thing I don't understand. And we'll do this outside, so somebody's going to have to volunteer for this, so I appreciate it up front. Because what we're going to do is this. If I were to tell you that one of you is going to go up on the roof, you're going to jump off the roof, and as you get close to the ground, you're going to throw your hands out in front of you and stop yourself. Hey, you guys would think I was nuts, right? That's crazy. But if I hooked you up to our trailer and pulled you up on the side and said, I'm going to swing you at your building, when you get close to the building, throw your hands out and stop yourself, someone would volunteer to do it. Why? It's distance, speed, and force. You get to go to the same hospital in the same ambulance if you swing and smash your face into something as if you fell down. So swinging, don't walk out away from things because you're coming back into something and it's going to be a problem. All right? You want to keep whatever you're anchored to as close to right above you or near you as you can get to eliminate the swing fall. Because I can tell you this, in a lot of cases, if a person would have done it better than what they did, they'd have been much better off in the fact that if you swing and fall, and all you do is go like this, and you cut your finger off right there, all right, it's a problem. Because if you were out in the shop and you cut your finger off, you come in and go, I cut my finger off, you need to take it to the hospital, and that'd be fine. But if you're going to hang there for 7 minutes until somebody can come and get you down with your finger like that, you're going to bleed to death. So that exact same little accident somewhere else exponentially gets worse when it's fall protection. So you can't take those chances. You have to make sure that you stay contained if you can help it. All right? And you'll see when we go outside, just by the sheer physics of it, you're going to move a little bit anyway. Even a perfectly straight drop on our trailer in a mannequin, they move. So don't get in your head that if I go to fall and I'll just go like this and I'll miss everything. Because that's not going to happen either. All right? When you fall, it's going to be kind of clumsy and clunky, and it's going to be a problem. But you have to use them right. They're great. These are great little pieces of equipment. All right? They will work absolutely everywhere a shock-absorbing lanyard works, and a whole bunch of places one won't work. All right? but you got to use them right or it doesn't make any difference. Let's just say you know you have the clearance distance that you need, all right? So you say, hey, I've got 22 feet from what I don't want to hit. I'm hooking this lanyard up. Everybody's happy, right? Great. Now you're done with doing your job, and you got to go over there to do your job. So what are you going to do? Well, first you look around, make sure nobody from safety's around, right? And you quick unhook it, hook back up over there, right? No. Well, you do, yes, but no, you don't want to do that. Anytime you are over 4 foot off of a walking working surface and you unhook, you are illegal. Or 6 foot construction, sorry, 6 foot. 6 foot of a walking working surface, you are illegal. All right, unless you are climbing directly down from where you're at. So if you get good at going like this and you hook on the other side, it's still illegal when you're doing it. All right. So how do you avoid that? Well, a single lanyard won't cut it. So again, all you have is a single lanyard, you have a problem. What you need to get is what we call a Y lanyard. That way you can hook this up to your back. You can take one leg and hook it off to your harness because you're not using it. Hook this one off to where you are using it. Before you move, this one comes off and gets hooked. This one comes undone. You walk to where you want to go, you hook this one up, you unhook this one. You walk to where you want to go, hook this one up, unhook this one. There's actually a guy that works for Chicago Bridge and Iron. He can walk on the underside of a bridge with a double leg lanyard as fast as you can walk across the top. And he's hooked and unhooked the entire time underneath. It's just because he's done it for so long and he's good at it, he knows what he needs to do when he's across now. All right? So again, double leg lanyards available. Make them in a bunch of different kinds. Again, cable version, web version, rope version, whatever you need. Now, let's just say that you know that this lanyard is going to work. And you say, but I don't have one of those lanyards, and I got to go to work tomorrow. So you go get your lanyard, and you hook it up. And then you go get your buddy's lanyard.
Oh, next question.
And you hook it up, right? So I get one lanyard, I got 2 lanyards, like so. I now have a double leg lanyard. I am as good as I was just a minute ago. Wild E. Coyote, super genius. Is this good or is this bad? Can you do this?
You tell me what we can. 'Cause I've done it.
Okay, this means yes. This means no. What's that? 1 hook per D-ring. You are allowed to have 1 locking snap hook per D-ring on a harness. So here's what happens. I have 1 D-ring, I have 2 snap hooks into it. If I take this lanyard, I have 1 D-ring with 1 snap hook in it with 2 legs off of it. All right? And for all you guys who are thinking it's all about the money, less hardware, less money. All right? Buy 2 of these, they're more expensive than 1 of these. So it's not about us, it's about the regulations.
What's the safety part?
All right, the safety fact is this, is that because these have to be locking snap hooks, all right, if you take and put a locking snap hook into a circle, the circle is only tangent in 1 spot. The snap hook is tangent in 2 spots, so we can't touch both sides. But if you take a second snap hook and add it into the circle, it's now tangent, the circle is now tangent, this is tangent in 2 spots, those numbers cannot equal each other. So that's where the problem comes in. Okay? So you just can't, it's illegal to do because there's no way to get around it because the circle is always tangent in 1 spot. Anything you add will make it tangent and you got kind of an issue. So we covered all the highlights that I wanted to cover, right? ABCs, anchorage points and anchorage connectors, body wear, and connecting devices. That stuff is all critical, and the connecting device, of course, you know, being the last thing, was the most important. With that, though, is care and maintenance, okay? You want to clean your harnesses, your retractables, your lanyards, your anchorage connectors, everything periodically. Not just give you all the time, but to do a proper inspection to see if the stuff is good or not, it would be best if it was cleaner than dirtier, right? But there's a couple of things that go with that, right? You do not want to dry clean it, right? You don't want to send it somewhere to have it done. If you are going to send it out to a company to have it cleaned, you want to find out exactly how they're cleaning it, right? Power washing, very bad for any type of fall protection. It sure gets it clean, right? It's going to come back real pretty, but think about it. You're talking about webbing that's supposed to be like this. You power wash it, it spreads it all out. Now it's weaker, all right? When they use power washing, a lot of times they use chemicals. You don't use any chemicals, you know, or any kind of solvents when you're trying to clean any of your equipment. The best way to clean any of it, all right, get some warm water in a bucket. I don't care if it's a 1-gallon bucket or a 55-gallon drum, just some clean, warm water, all right? Take a liquid soap, any type of, solid liquid in that regard, and just squirt it in there and froth it all up a little bit. You can take absolutely everything I've showed you today and put it in that bucket full of soap, all right? Get a regular little nylon brush, not a wire brush, nylon brush, scrape off, whatever dirt you can get off, wipe it off a little bit, dunk it in some more soap, and just take a regular bucket of clean water or a hose without any type of nozzle on it, spray it off a little bit, hang it up and let it dry.
Is there any kind of soap you'd recommend? I mean, is there a general rule like in the military we say if Mama uses it to wash the dishes, it's safe to use it on your...
Yeah, exactly. That's exactly right. Yeah, exactly. Any type of liquid soap at Dawn or whatever kind of dish detergent, stuff like that, will work just fine. There isn't anything of those kinds that are that harsh that we worry about. Well, you don't want to get stuff with the granules and stuff in it because it gets in the webbing and then it acts as an agitator, and then that little bit of whatever it is can wear out a spot of webbing, and you don't want that to happen. All right.
What would be the lesser of two evils, leaving it kind of greasy or getting it wet and soapy?
Well, like I said, you'd really rather have it wet and soapy and then let it dry to get it clean, and then you'd be able to inspect it much easier because you'll know, is that a big old dirt spot, or is that a burn mark, or is that a, that's what we're looking for. The reason why I want it cleaner is because I want to be able to see it better. I want to be able to tell what I'm looking at to see if I can put it back in service or not. Okay? So again, the whole idea behind cleaning it is just so you can do a thorough job inspecting it. And that's really kind of the key to the whole thing. When you do inspecting, you're looking for loose and broken stitches. You're looking for your tags. So basically, if you remember when we started this morning, I said pick that harness up by the back D-ring. Right? You're going to look at it to make sure that the webbing is all straight before you put it on. You can take 1 minute, is all I'm looking for, is for you guys to look at this and go, yes, the D-ring's in good shape, it's not corroded, doesn't have any cracks, any big pit marks on it, it looks good. Looking at the webbing, because you're going to untangle it anyway, go ahead and pull it out and look at it. Does it have any burn marks, cuts, rips, frays, tears, whatever it is? Look at it and say, okay, I'm going to look at all the webbing, go. Let's see, there's a little dirt spot right there. Nope, that's all it is, a little dirt spot. No big deal. So you keep looking. You want to make sure you look at the stitching. Okay, all the stitching is actually there. Are the tags still attached? Right? If there's no tags on a harness, they can't tell you the manufacturer, the manufacturing date, some type of serial number. There's no way to track the harness, then the harness is no good. All right? You have to be able to say, here's the harness, and this is the one I know because it has some type of number system to it. And you can number them yourself. I mean, there's all kinds of extra ways you can write on them if you want to change our numbers. That's not a big deal, But you have to be able to track it and not just, if this says Bill, it's mine. Okay, well, anyway, you can write Bill on there. You got to be able to go back to the paperwork and go, is it Bill 1, Bill 7, Bill 9, whatever number it is harness you own, that's what it has to say there, right? So again, you want to check all the buckles. Right? And again, if you have the tongue and grommet buckles, don't go, well, the third grommet's missing, but I'm a 5th grommet guy, so it's not a big deal. If it fell out, something happened to it. These things just don't fall out, right? So if there's anything wrong with the harness, it's got to be taken out of service, right? So then you go from there to your lanyards. The same thing with the lanyards, you want to look at the snap hooks. They have to open and close freely, right? If you have to smash this thing on the table to loosen it up enough to try to squeeze it to open it, probably bad. If you squeeze this open and it stays open like this, and you got to try to figure out how to beat the thing shut to close it, it's bad. All right? You don't want to use that because again, if you're using it and this happens to get pushed open and it has a tendency to stick open, then guess what? Now you've got an open snap hook, and if you fall, it's going to be a problem. All right? So again, you don't want to do that stuff. You want to take. First thing you want to do with our lanyards, you want to look to make sure that the flag's attached. Then you just want to take the webbing, kind of pull it away like this, because remember, it's all scrunchy, so something can happen inside of this part. So you just want to pull it away real quick and look at it to go, okay, am I looking for stitches? I'm looking for rips. I'm looking for tears. I'm looking for any kind of big discoloration. There's a little fuzz right here. No big deal. Keep moving. Look again. Little fuzz right there. No big deal. Not a rip stitch. Look at the stitching. Check the other snap hook, you're good to go, right? Self-retracting lifelines. For self-retracting lifeline, you again want to check the snap hook, make sure the snap hook is good. You want to check the carabiner, make sure the carabiner is good. Okay, again, opens and closes freely. Then you want to make sure that the unit itself works. So again, does the drum work? This means the drum works. It's rolling in and out. Does the brake work? Yes, the brake works. Now does it go back to rolling in and out again? Yes, okay, good. If you go like this and all day, you can do this all day. This will never lock up enough. You can't pull it hard enough to lock this up that it shouldn't go right back into go into freewheel mode in the process. If it does, it's bad. All right? Once you check all that, you want to just take a second, take the webbing out all the way to the end, and then you want to check that webbing all the way to the end of the housing. All right? Because again, just because you've only used it 3 or 4 feet doesn't mean somebody else didn't pull this out and do something with it. That the end of this could be, you know, burnt, ripped, tore, whatever. So you just look at it real quick when you're putting it back inside. Make sure it all looks good. Make sure your flag, there's a flag on all of our retractables as well as our lanyards. If this little red flag were to pop out, that means somebody's activated the system. Nope, so you're good to go. All right? So again, that's the kind of stuff that you're looking for. Same thing with your anchorage connectors. If it's a cross arm strap, if it's, you know, if it's one of our D bolts, not really too hard. You just kind of look at it. Is it pitted, cracked, broke? Nope, good. Okay? So again, we're just looking for a 1-minute thing for you guys to say, if something were to happen to me today, is this all going to work and work properly in the process? Because you are the first line of defense for yourself when you put this stuff on. All right? Because if all you do is rely on an every 6 month or once a year inspection by, you know, your competent person, there's all kinds of bad stuff that can happen in that time frame that you're the one that can see it way beforehand and bring it and go, hey, I don't know, does this look good? Somebody else might look at it and go, yeah, you're fine. Okay then, no big deal. Right? But it's better to be safe than sorry in this particular case. Okay? Okay. Best inspection model there is, if in doubt, throw it out. That's all it is to it. Because it is not worth anybody's life for what this stuff actually costs to say, oh, well, we're trying to save a buck. It costs exponentially more for 2 aspirin at a hospital than it does for this entire outfit. Because they charge exponentially at the hospital for aspirin. But besides that, it is not worth your life or an injury for what this stuff actually costs. All right, so keep that in mind. All right, so bottom line is we can prevent injuries and death if you guys participate, if you do what needs to be done correctly with the equipment. But that's the key. You have to wear it right. You have to use it right. You have to participate in having this stuff done. Okay? It is an active system. It is not passive. All right? So to do it, you have to do it properly. And if you do it, like I said earlier, I can guarantee you it will work every single time without fail. Okay? But again, if you didn't remember anything else about today, 18.5 feet for shock absorbing lanyards. Self-retracting lifelines can always be used instead. Train never to walk away from them unless you're setting them up so that you can't walk away from them, like on a horizontal on a platform or something like that. You do not want to swing fall if you can help it. If you remember nothing else but those 2 things for today, will accomplish a whole lot, believe it or not. Because those are what kill people, those 2 things right there.